In this video, we will see Castigliano's theorem to find the deflection. So, theorem says that the partial derivative of a total strain energy. So, we have strain energy and its partial derivative in a structure with respect to any force. So, del U by del P, P is a force, at any point is equal to the deflection. So, it will be directly equal to the deflection at the same point. So, for any point, if we want to calculate deflection, we have to differentiate total strain energy with respect to force at that point. We will get deflection at that point, and the deflection will be in the same direction as that of the force. So if we say U is a strain energy of a body, U we know that it is integration 0 to L moment as a function of x square dx divided by EI. So if E and I is also varying with respect to x, we have to take like that, as a function of x we have to put and then integrate it. Here I have taken it as constant. Now if we see this theorem in more detail, then this is a body. We have P1 force in this direction, P2 in other direction. Moment at O point is MO. So P1, P2 and MO are three forces we are acting. So deflection at point 1 will be equal to del U by del P1. So if we calculate total strain energy of the body and then we differentiate it with respect to 1, then we'll get deflection at point 1, this point, in the direction of P1 only, same as the direction of P1. At 2 point, if we differentiate del U by del P2, then we get deflection at point P2 in the same direction as P2. And if you want to calculate slope at point O, then we have to use del U by del M naught. So moment will give the slope at the same point where moment is applied, and deflection we get by differentiating with respect to force at the same point where the force is applied. So now if we are not having the load and the load p value and moment value at so let's say we want to calculate at this point, then if you want to calculate deflection at this point, then assume deflection by giving a dummy force and later put p value as 0. So assume that there is any force which is acting, and after finding y1 or deflection at this point, you simply put the value of that particular force wherever you have taken the variable. Let's say here the force is x. So after calculating everything, you put x equal to 0. So that will be the final value of deflection at this point. For calculating the here slope value, you assume, let's say another point here we have to calculate slope value. So assume a dummy moment m or m dash, and later after finding and doing all the process, put the m dash value as 0. So we'll get the slope value at m. So like this we have to assume a dummy values. So these three formulas are basis, these both formulas same only. I have just written it p1 p2 so that you get feel that we'll get deflection in the same direction as the force. So this one and two other main formula which we have to remember, and of course the strain energy formula. So here the first example we have to look at, this is a cantilever beam, and we are applying load at the point A. So now we can write moment at x, random moment is w into x. Now after calculating strain energy, we have to differentiate it. So first, to calculate strain energy, U is equal to mx is wx. So w minus wx, because it is a hogging position, it is bending downward. So minus wx whole square dx upon ei. So after integrating it, we get w square l cube by 6 ei, because x square different x square integration is l cube by 3. Here it is 0, here it is l, that's why. So over the total length we have to do it. So after getting u is equal to w square l cube by 6 ei, we have to differentiate with load w, whatever the load. Here p1 was there, so we have used p1. Here w is there, so del u by del w is deflection at point A only, in the same direction as w. So if you differentiate it, w square will be 2w l cube by 6 ei. So final value will be w l cube by 3 ei. So we directly get the deflection at this point, which is A, in the direction of load w. So that this is the deflection. Let us look at one more example. Here we are giving a pure moment here, and if we take the moment at any random point, it is minus m. W is absent here, so pure moment m value is only there. So moment is constant at each point. U value is integration 0 to l minus m square dx upon 2 ei. So if we integrate it, it will be m square l by 2 ei. So we get u value, which is strain energy. Now if we differentiate with respect to moment m, we get slope at point a. So after differentiating, m square will be 2ml by 2ei, so ml by e. So this is the slope value at point a. So this is how we have to apply both this formula. You can practice more problems and get more clear idea. This is very helpful technique if we directly have the strain energy value given, and sometimes they ask direct formulas also in the questions. So this was it for the video. Thank you for watching this video.